Hi everyone, this video we're going to do a bit of circuit patch design or sound design if you like. We're going to grab the circuit editor which is free to download off the Novation website, and we are going to go through how to create your own patch. So let's get stuck into it. We're going to go into Synth 1 here, and we're going to click over here. We're going to initialize the current patch, and what that will do is that will just give us a standard Sawtooth synth tone, one oscillator, and basically all those settings are out. But if we had a patch already loaded into here, you're going to get something sounding a bit different. All right, so let's initialize the current patch, and that way we can start from scratch on what we want to do here. Now, a little bit of, I guess, housekeeping around the screen so you guys can see what's happening. The main screen here in the middle is the actual circuit editor. I'm going to go through that part last. Above me is the circuit cam. I'm here, and down, no, that way. Down there, you'll see a spectrum analyzer and a oscillator, and they are taking the audio feed from the mixer, which is at the moment I'm using just an MX1. Now, with the MX1, it's recording the sound that you'll hear in this video, but over here on my Ableton screen, the actual audio coming in is directly digitally in through that channel 5 and 6, so there's no effects or anything like that. All right, so let's go back to here. I guess it's always important to know. All right, so now the main screen, which is in the middle, which is what we really are here for, and this is our circuit editor. And what this enables you to edit is the two synth sounds or synth parts on the circuit, and that is actually pretty huge because each synth has 6 voices each, and 6 voices is a lot for this little box here, and to have complete control over each of these two parts with 6 voices each is even better. And if you're going to make your own music, I always recommend to create your own sounds, put your own samples on, and use your own tones that you've created yourself. That makes it a bit more unique, and it separates you out from those who are lazy, who make music and they're just using the patches that come with the circuit itself or Novation, or they've bought someone else's third-party thing. So this video isn't about loading samples onto here. If you want me to do a video on that, please let me know in the comments below. I'd be happy to do one. I just want to see what sort of feedback I get with this one first. And anyway, let's get stuck into doing the synth sound. So we'll start with Synth 1. We've initialized the patch. Now let's see. We can actually change the name of the patch. So let's call this Tutorial 1. So we know where this has come from, okay? And we're going to give it a genre, are we? Maybe we'll do the sound first and we'll worry about the genre later. So in this section here, you actually have library control, and you can actually store your libraries on your computer. Yes, you can send your sounds directly to the circuit, but you can also store them on your computer, and you can manipulate what is actually in this whole library bank on the circuit itself. So that is actually really cool. We don't need to go into that just today, because really all we want to do is we want to muck around with the sound. Now, the next section down here, where it says macro controls, that section refers to the 8 knobs that go across the top of your circuit up there, and you actually can change those macro controls on here. And I think part of the patch editing requires, because of the circuit's unique design, I think that requires us to touch that. So what I'd like to do is I'd like to skip that for now, and we'll come back to that once we've actually got a sound that we like. And then those macro controls will actually be something that we can fiddle with. The Synth Engine control is probably where we should start. Now, each of these boxes are labeled Oscillators, LFOs, and then underneath you've got a mixer, envelope section, and there's 3 envelopes to play with here. and you've got a filter section, and then down below you've got effects and EQ. Now I'm not going to touch every single aspect of this in this video, but I do want to explain a little bit about what this section means. Over on the right, you've got the mod matrix. Now, this is actually really quite in-depth for a little synth, like a circuit. The fact that you've got 20 slots that you can assign different modulation controls to is huge. So for sound design, you have got a lot of cool stuff here if you really want to get crazy with this. In fact, the actual Synth Engine is the Novation Nova Synth Engine. You'll see it in the Ultra Nova, the Micro Nova. So those Novas, it's a digital synth, but they're actually pretty decent sounding. Okay, let's start with oscillators because that's what is generating our sound. Now notice that there are two oscillators. There's oscillator 1 and oscillator 2. Now, when you're editing the oscillators, you must make sure that you're selected up the top here, the right tab, otherwise you could be changing the wrong oscillator. Once we've set our oscillators, down here in the mixer is where we can hear them, and at the moment you can see that oscillator 1 is the only one that's turned on down here. So for now, what I want is I want a sawtooth wave, and on oscillator 2 I want to change this waveform to a square. Now you just keep changing it around here until we get to square. There it is, there. Let's just listen to the sawtooth wave. Right, down the bottom you can see the oscillator showing that sawtooth wave. Now let's turn off this oscillator 1 off, and then all the way on for oscillator 2, and now you'll hear a square wave. And then you can see down the bottom on the oscillator section what a square wave looks like. So let's now combine the two together. It kind of sounds a bit buzzy. What I'd like to do with the second oscillator is drop the semitones down 1 octave. So you just do that by adjusting the semitone. -12 is what we want to do. There we go, -12. Now listen to it. Nice. Okay, so for now, oscillators are done. This is just a real basic sound that we're going to design. For now, we're going to skip the LFO section. We will come back to this. We're going to use the LFO. We've just played with the mixer. Now I want to use the envelope. Okay, so for those who don't know, an envelope is basically the ADSR, attack, decay, sustain, release, part of your sound. So attack is the time it takes for a sound to reach its peak, the attack point. So when the attack is 2, it's going to reach it almost straight away. As you can see, if I increase my attack to all the way up to the 127, which is the max, you'll hear it really gradually get to that peak. And it's almost like forever, okay? So for now, let's just leave the attack as 0, which is 0, sorry, which is straight away it turns on. The next is decay. So decay time is the time taken for the subsequent rundown from the attack level until it reaches the sustain level. I'm going to put a graphic up on the screen right now, which will show a visual graphic explanation of an ADSR. And what's really important to notice is bottom row is the time, and the vertical row is the amplitude. Now amplitude is the volume. The sustain level, so just here, is the level during the main part of the sound's duration until the key is released. And you see me press a key and I release it. That's sustain. So if sustain is at 127, that means it will just be completely on until I release the key. But if I reduce sustain to a number that's below the decay, listen to what happens now. So you can hear the decay goes higher and then drops down to where the sustain is until I let go of that release. So that's how you can get kind of like a little burst sound, and then it drops to a sustainable sound, and then you can set your release. Now release is how long the sound to hang around after you let go of the key, right? So if I just drop that right up to something really high, I I've let go of the key and it's still hanging around, right? I'll do it again. I'll tell you when I let go of the key. Now. So one of the most important things about polyphonic synthesizers, I feel, is that if you've got the same tone, but two different keys being pressed, like at different times, you'll hear that sustain envelope apply at different intervals to each note. Now listen to this again. So that lower C should fade out before the D sharp at the octave higher, right? Now, if I did all 6 notes, because this is a 6-voice polyphonic synthesizer, you'll hear all the notes apply their envelope at different intervals as when I press the key. So let's do. So it's important to understand how envelopes work, because I've just decreased the release now to 61, which is just below half. And it kind of sounds like sound is a little bit up there, but not too long anymore. Now, another thing to note on this synthesizer, the amp envelope applies to both oscillators. Okay, so both oscillators will go through the same amp. All right. It's only the notes. Now that's not really that great, the sound. I want to actually have a bit more release too, by the way. Probably about there, and I probably want to have a little bit more attack. I don't want it to be too stabby. Here we go. That softens that attack a bit for us. All right, so I just increased the attack to 33. We've got an 84 release, and I kept the decay and sustain. So I still have that slight attack decay before it drops to the sustain level. So see how it did that? Do it. Listen again. It will go up and then down to the sustain level. Watch. So you can actually see on that spectrum below it doing it. Watch it again. And there's the sustain level there. Okay. So now we've got 2 different oscillators. So we've got a square wave and a sawtooth, and we've got an envelope already. Pretty cool. And that sounds not too bad. But the next major area of the synthesizer is this area, the filter. And this will help you change the audio coming out. So the frequencies that are cut off by reducing this frequency knob here. So let's listen to that. So you can see as the more I reduce that number, it's just leaving those low end frequency, because this is called a low pass filter. And you can see down the bottom here, it says it's a 24 dB or 24 decibel low pass filter. Now what that means is it's allowing the low sounds to pass, and that means it's filtering the high sounds, which is exactly what it's doing. So if I bring it back right up, you can hear all those high sounds, and then so you can see now that is really kind of changing. All right, so the next part of a filter that's really important to know is this one here, the resonance, or res it's called here. So basically resonance actually boosts the frequency at the cutoff point. The more you boost it, the most where that frequency increases, you'll get this point where it can actually self-oscillate, where the actual sound will eventually turn into a sine wave, and there's a whole bunch of other cool stuff you can get on that. But anyway, let's just have a look at our resonance, right? So we're gonna bring that up to half, or around about half. I'll try and get it about there. And as I adjust the frequency, it's kind of got a wet, sappy sound to it. And if you look at the spectrum over here, so as I reduce the frequency, you'll notice that that oscillator picture down the bottom right there, you'll notice that the actual waveform kind of smooths out. I'll go all the way to the top and see how sharp it looks, right? And then let's reduce it down. And it's almost a sine wave there. Pretty crazy stuff. And the more you increase your resonance, then you'll get to that self-oscillation. Wow, blow your ears out. Now, with filters, I don't have an opinion. You need to have your own opinion. Play with them until you get a sound that you like. And then once you've got that sound, stick with it. So, LFOs, right, over here. What is LFOs? Well, they're low frequency. So there's another oscillator in your synth. In fact, there's actually another 2 oscillators here there because there's 2 LFOs. But they're low frequency oscillators because you can't hear them. That's why they're low frequency. But what they are used for is they're used for modulation. So what's modulation? Well, modulation means that I can apply this oscillator to a whole bunch of destinations within the synth. So for example, this is a sine wave. It says here LFO sine, right? The rate is 68 here, and this is where now we jump to the mod matrix, right? So now I'm going to grab that LFO, LFO1, and I'm going to apply it to oscillator pitch. This is very obvious because you'll hear the pitch go up and down, right, at that rate, 68. So let's do that. Nothing happens until we increase the depth. So I don't want that for this sound, but you can actually audibly hear the rate of that sine wave. Now you can change the waveform of this oscillator. So the sine wave is that smooth waveform, right? You can change it to a triangle or sawtooth. Right, let's listen to the triangle. It sounds very similar to a sine, but the waveform is straight up on an angle and then down. It doesn't smooth off, so it's not quite as smooth as the sine wave. Then we've got a sawtooth, so you'll hear this jump up and then slowly drop down. Let's do it again. Right, now that means that that sawtooth is jumping first and then gradually dropping off, because you can listen to it kick in. Right, so it goes boo. You can hear it gradually drop off. But we can invert the phase of that. See that? That's pretty cool, and that's just run by the phase offset there. So sawtooths are pretty cool. Now what about a square oscillator? And that will just be like an on and off. And you can get that to almost be, I could do that as an octave if I do that. Maybe. Anyway, you can play with that. I actually do want to have a square oscillator here, but I'm not going to adjust the pitch. I'm going to adjust the oscillator 1 level, and I'm also going to do the same for slot 2. But this time we're going to have oscillator 2 level. So what that'll do is that will turn our oscillators, because it's a square wave, it'll turn them on and off. Let's listen. Now that's subtle because it's at 24. We can make that really obvious. I think it's better subtle. For my sound, I like it around, doesn't have to be perfect. 25, yeah, that'll do. Now, we've got a second oscillator. So this is actually beating, right? We want this to sync to, let's say, an eighth, and we want it to be key synced. So that should be synced to the clock now. So if your circuit has got a beat running, that'll have that pulsing sound to it. Now that's going to be really cool when we get some bassy, pulsy sounds. Let's do the second LFO, and we want this one to be a sine. So the second LFO, I'm going to, I'm happy with that rate for now, but what I'm going to do is I'm going to assign it to LFO2 source, and I'm going to assign it to the filter frequency. I'm going to make this really, really strong. Now that's really fast. It's weird, 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 weird. So that's actually, that's literally turning my frequency knob on, off, really, really fast in a sine wave form. Let's slow it down. Let's get some. Faster than that, so you can hear it. Oh, there we go. So what's important about the two oscillators on the LFOs is one is synced to the clock of the circuit, so the beat, the BPM, and the other one is free running. See there, it says free running. So that means I can have that filter sound. Okay, I can have that just free running. I can make it faster. All right, now, let's play with the waveform on that oscillator, on the LFO. Let's get it to, so we've got a sample and holds here. There we go. Now let's just turn off these slots for a sec. There we go. Sounds pretty cool. I've always loved this sound. Let's sync it. Let's do a 16th. Now that effect is really cool, but I think it's competing with our oscillator level effect. So let's not do that. Let's change that back to something like a sine wave. And let's change that to free running. And let's turn these back up. Synthy sounding, which is what we want because it's a synth, guys. All right, let's take that release down a bit. It's still a bit long. That's really cool. It's got a bit of unpredictability to it. that could be cool, quite rhythmic sound. All right, so let's say we've made this a bass. I really don't care what sort of genre it is. I don't believe in genres, guys, sorry. So we'll call this Ramsey bass. Okay, done. Now I want to save that single patch to disk. I'm going to just call it Ramsey bass circuit patch. Save. Initialize. That's our patch. Let's initialize that patch again. So it's gone. So we're going to click load. Patches, done. All right, so let's see if it's back. Yay. All right, so now we have patch management on the circuit. So yes, in the circuit, you can store 64 patches or whatever it is in here, right? You can store them all in here. But you can actually, you know, store this patch. Let's call it Ramsey bass. And I want to store the patch on the circuit, and now you'll see Ramsey bass is at number 40. Where's 40 gone? Right, boom, I've overwritten my circuit. Done. That's the first synth tone. Let's do the synth 2 part. Let's initialize. This one I want a string sound on this one. All right, so what does a string sound? Well, Sawtooth does, but a nice envelope on this. Let's go with a good long release. Not that long. And a bit of an attack, a bit more of an attack. And should we do a second oscillator? Why not? Let's get a slightly detuned, right? You hear that? It kind of just made it sound a little bit thicker. And then if you notice too, the second oscillator isn't as loud as the first, so just do things in subtleties and you'll enjoy them. Now, next thing for my synth tone, I want to just reduce some of that harshness of that Sawtooth. Quite happy with that, so let's call this Ramsey string, and who cares about genre? A techno genre. And this time we're going to call it a string, and we're going to save the patch to disk. Ramsey string circuit patch. Okay, and we're going to store the patch there. If we go to the first synth, we've got our bass. And the second one. There's our 2 synth sounds. What about these macro controls? I want to be able to control the filter of that synth as I just that first macro control. So let's go into here and go filter frequency, depth, here we go. So that's working now. And I mean, you can make these macros do any of these things here. It's crazy. We've covered macro controls, we've covered oscillators, LFOs, mixer, envelopes, filter. What about some of these effects down the bottom? This chorus might sound good. Oh, it's Richie. And we actually have a phaser here too. Alright, so that sounds cool. Let's store that. And let's go back to synth 1. And let's get some distortion happening on this bass sound. That sounds cool now, so let's store that. Alright, now the last thing we want to do is we want to play with the session, because the session actually has the effects controls here, and the effects engine is kind of like a send and return, and you can actually apply reverb to our bass sound, for example. Let's apply it to our synth engine. Now I want to have a bit of a delay on that bass sound. Alright, and we've got that reverby sound on the synth string. Bass. And in that session control, there's so many more things you can do. There's another filter, which is the overall filter of the whole synth. You can even, again, mix the two synths here. There's also some side chaining that you can do with the synths. Anyway guys, that is probably all we need to do for this particular session. It was really just about getting this synthesizer knowledge into you guys. Hopefully it was enough. There's a lot more you can do on this, a lot. But this is a basic, so we've got a basic sort of bass sound and string sound. There's so many more things we can touch on this, and I want you guys to tell me what you'd like me to show in the Synth Engine, if you want me to show you how to do stuff. Another video coming up, we're going to talk about how to do our own samples, and we're going to load those samples into the circuit. Now when I say I'm going to do my own samples, I don't mean just downloading samples off the net. I actually want to record my own samples, and whether they be percussive, drums or even just vocal or whatever. I want to record those and I want to chuck them into the circuit. So then we're going to make a track using our own synth sounds, our own sample sounds, our own drum sounds, and that will make it completely unique. And then that will actually show the full power of what the circuit can do. Stick around for that. Hit the subscribe. Don't forget to click like, because you're not clicking to say that you like me. You're clicking to say that you like what you learned and the fact that it was free. You didn't have to pay someone to teach you. Remember that. These videos are free. I also have some information down below me here. Please check out my Patreon page if you really do want to support what I do. That's the way to do it. The crappy ad revenue I get from YouTube is not a lot. Thanks again. We'll catch you later and have some fun with your circuit. That's the main thing. Catch ya.